Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today on What the FOOF, we're talking about metal fires. When you first start learning about fire and combustion, you're often told about the fire triangle. The fire triangle describes three things that are needed for a fire to occur. The first is a fuel source, the second is an oxygen source, and the third is heat. A simple demonstration of this can involve having a candle burning and placing a glass over the top of it, and the candle goes out. The explanation being that as the candle burns, it consumes the oxygen in the air inside the cup, replacing it with carbon dioxide, and eventually there is no more air inside, so no more oxygen inside, and it goes out. An example of removing the source of ignition or heat from a fire is blowing out a candle on a birthday cake. It's not to do with the carbon dioxide in your breath. There's still plenty of oxygen there, but rather as you blow, the flame, the heat source, is pushed away. It's removed from the candle, and so it goes out. A very practical example of extinguishing a fire by removing its access to the oxygen in the air is if you are cooking and your oil catches fire. If you were to add water to this, the oil would float on top and continue burning, could even splatter and spit, spreading the fire. So instead, you take a lid and you place it over the pan. The oxygen in the air inside the pan will be consumed and the fire will go out. So now, I would like to describe to you a demonstration that is often shown to chemistry students. I wish I could show it to you myself, but I have no way that I can safely do this demonstration. And I have a very simple rule when it comes to chemistry and science. If you cannot do it safely, you cannot do it. Now, back to the description of this demonstration. A block of dry ice is placed on a platform, in the center of which is placed some pieces of magnesium. The magnesium is lit and a second piece of dry ice is put on top. Dry ice is the solid form of carbon dioxide. It's approximately -80 degrees Celsius, so it is certainly not warm. There is no heat from that surrounding dry ice. It is also carbon dioxide. It has sealed them between the two, so there is no longer access to the air in the atmosphere to get inside. So, based on what we said before, we might expect it to go out. However, what actually happens is the center of the dry ice begins to glow brightly. White smoke begins to come out from the gaps between the two pieces. And eventually, when the light dies down and you remove that top piece of dry ice, there is a black solid, reminiscent of a charcoal briquette in the center. So what's happened here? Why hasn't the dry ice been able to put out the magnesium fire? The answer comes down to the type of fire we have. Metal fires are much more aggressive than our regular fuel fires. They are able to pull oxygen from water or from carbon dioxide to keep themselves burning. This is why we end up with that black puck. The magnesium fire has pulled oxygen out of the carbon dioxide around it, leaving behind carbon. That white powder was magnesium oxide, the product of the combustion. So how could you put this kind of fire out? Well, the answer comes down to the class of fire extinguisher used. For example, this is the kind of fire extinguisher you will commonly find in a household kitchen. And if you were to look at it, it says it is fine for class A, which is a solid fire, so trash, wood, paper. Class B, liquids, or Class C, electrical equipment. There is a fourth class that is not mentioned on here, and that is Class D, metal fires. If you're going to be working in a situation where metal can catch fire, you need to have a specific type of fire extinguisher ready and a plan for what to do should you need to intervene and extinguish the fire. The simplest Class D fire extinguisher is dry sand, and it is important that that sand is dry because metal fires can pull oxygen from water. Some metals, like sodium or lithium, don't even require a source of ignition. If you put them in water, they immediately start to react. So it is very important that that sand is dry. However, the dry sand is not just a total panacea. You need to understand what type of metal is burning and what is an appropriate class of dry material to use. You can use sodium chloride or even charcoal, and in recent years, copper has also been used as a Class D fire extinguisher. But why do metals react so violently? Well, that is a story for another time. I hope you have enjoyed this video, and if you have, please make sure to like, subscribe, and share it with your friends. And if there is a topic you'd like to see covered in a future video, please put it in the comment section down below. Thank you, and I hope you have a wonderful rest of your day.